this computer. Oh, there we are. Okay, so I'm gonna record this lesson as in some of you might not be here. So I will just have to record it for the others. So before we start, let me just do a brief introduction about myself. So my name is Tiger. Okay, I'm just trying to introduce myself right here. So my name is Tiger, and you can just call me Tiger, all right? And
Jenny, no!
Sorry. Just please be quiet for a moment. Okay, so I'm just going to be the tutor of year 5 and the upcoming year 6 pupils. And then today we're just doing a lesson on linear algebra and word problems, okay? So it's going to be much about the equations and whatever. Sorry, I'm getting a little bit of background noise over there. Yes, I have a puppy called Walnut. That's right. Thanks, Gracie. All right, so let's start with our lesson. So first of all, I would like to know how many of you have heard of algebra before? Okay, if you have heard of algebra before, you can either raise your hand or just type a 1 in the chat box, okay? You can type a 1 in the chat box if you have heard of algebra before. All right, that's many of you. Brilliant. So basically, what algebra is doing is that.
What algebra?
Sorry, who's that? Can everyone just try to turn your mic off for a moment? And because like there's many of you, so I don't know who's speaking at the moment. So yeah, if you have any questions, feel free to type it in the chat box. And well, basically, if you have any questions, just type it in the chat box so that I'm just gonna know. All right. Okay. So what algebra is doing is basically that I have an equation with 2 expressions on both sides. For example, 2 adding 3 is 5. So that's an equation, right? That's what the equal sign is for. It means that the quantities or the numbers on both sides are the same. So for an equation, the key concept is that whenever we do the same thing on both sides of an equation, the equation is still an equation. Okay, so for example, I now want you to add a 3 to both sides of this equation. 2 adding 3 is 5. Can you just add a 3 to both sides? We can't hear anything? No, that's weird. So try to add a 3 to both sides and see what happens, all right? So now on the left-hand side, I have 2 adding 3, and we know that's going to be 8. On the right-hand side, I have 5 adding 3, and that's going to be 8 as well. So again, we can see that both sides is still an equation, right? So next, I want you to, for example, instead of adding 3, I want you to take away 3 from both sides and see if it is still an equation. So on the left-hand side, we have 2 adding 3, take away 3, that's 2. On the right-hand side, I have 5 take away 3, that's also 2. So that's still an equation, all right? And the same applies for multiplication and division as well. So basically, we know that if I do any operation at the same time on both sides of the equation is still going to be an equation. All right, so that's what we are starting with. And the next thing we are looking at is something we called unknowns. So in this lesson, we are just trying to use x as the unknown. But of course, apart from x, the unknown can be any letter. Yes, Yanchen, is there anything you want to share with me? No?
It was an accident.
Okay, it's just an accident, all right. So for the first equation, we can see that there's this letter X right there. So it means that's something we don't know. It means an unknown. And if we want to find this unknown, I can just do it by doing different stuff on both sides of the equation. For example, we know that 16 minus X is 3. So now all we need to do is to move the numbers onto one side and X to the other side, so that I have X term on one side, numbers term on the other side. So I know that X is equal to the number, okay? So here's what we can do. First of all, we write down the equation 16 take away X equals 3. And then the next step is we can see that X is on the left-hand side, where 3 and 16, the two numbers, are on both sides of the equation, so that I can't directly write down the answer for X. What I can do is that I can take away 16 from both sides of the equation. So that on the left-hand side, I have 16 take away 16, take away X. On the right-hand side, I have 3 take away 16. So I can cancel out the 16s on the left-hand side. And now I have minus X. Remember, that's pretty important because we are taking away the X, right? Minus X on the left-hand side and 3 minus 16 on the right-hand side. So that's just a little bit of negative number calculation, where I believe you most likely know about it through the number line. So I have 3 over there. If I minus 16 from the 3, I first take away the 3 and I take away 13 more. So it's going to be minus 13. Yeah. So minus X is equal to minus 13. So what should X be in this case? You can just type your answer in the chat box to let me know. If minus X is minus 13, then what is X? Yes, that's right. Remember, we can do the same thing on both sides. So if minus 3 is minus 13, it means that X is just 13, because I can cancel out the negative sign on both sides. So that's the answer. Yes.
I think there's another way you can do it.
Yeah, of course, there's many ways we can do it.
Yeah,
we can move.
Like is 16 minus 3. That makes sense.
Okay, yes, that's making sense. We can of course move the X to one side and the numbers to the other, but that's going to be another technique that we learn about next. So for now, let's just try to stick to this way first. All right. And later on for some more complex equations, because like there's only one X term in these questions. But then later on, there will be more X terms in these questions. So that's when we need to move X around. All right. And in the second question we have, now we can see that there are 3 numbers, 12, 4, and 8, where there's just one X. So what we can do is that we can just try to do the calculation first whenever we can. All right, try to combine some of the numbers. So I have 12 take away X, adding 4 is 8. And on the left-hand side of this equation, I know that, well, the minus X and the plus 4, they can be swapped. Because for addition and subtraction, it doesn't really matter which one I do first, right? So I can just add 4 to the 12 first, so that I have 16 minus X is 8. So now I just have to take away 16 on both sides, such that on the left-hand side, it cancels out. And what we have left is just minus X, right? Because we didn't cancel out the sign, so the sign stays on the left-hand side. And then on the right-hand side, I have 8 minus 16, which, well, if you use the number line, I'm not going to demonstrate it again. So it's going to be -8. So if -x is -8, it means that x will naturally be equal to 8. All right, so that's the whole story. All right, Mia, which part of it do you not understand? Maybe you can just let me know.
I don't understand. How is it -a? I think it should be a.
Oh, 8 minus 16 is not 16 minus 8. So you can see that, well, if I have the number line, this is going to be 0. This is going to be 8, right? So if 8 is minusing, like taking away 16, first of all, we are taking away 8 from 8. So it becomes 0, right? And then we are taking away another 8. So it becomes -8.
Okay.
All right, so that's how it works. That's how it works. You can just try to cut it into 2 sections. One is like the positive section until it becomes 0. And then the other thing is that you take away whatever is left from 0 so that you get a negative value. Okay, so that's how we do the negative calculation. And this is kind of important, which we are going to learn about the negative calculations systematically in our 3rd revision class. All right, the 3rd revision class is going to be on the negative numbers calculations and the decimals. Okay, so the last one.
Okay,
so the last one right here, again, I have 1x only, but I have 4 numbers. So what do we need to do? If I have 4 numbers, I just need to calculate whatever I can first. All right, I just need to calculate the numbers that I can. So first of all, just write down the equation, making sure that we are copying every term down. So on the left-hand side here, we have 46 take away 23, and we know that's 23, right? And of course, for the -x, we just keep it unchanged. On the right-hand side, we have 85 divided by 5. So it's going to be 17. 17. Okay, so now I have an equation just like what we have in the first example right here. So I can take away 23 on both sides because I just want x on one side, nothing else, just x. So that's the reason why I'm always removing the number on the x side. You see that? So how we remove the number on the x side is just by doing the opposite calculation of it, the opposite operation. So I have 23, I just take away the 23, right? So it cancels out. But remember, I need to do the same thing on the other side as well. So that's the reason why I'm taking away 23 on the right-hand side as well. So now I have -x on the left-hand side. And on the right-hand side, I have 17, take away 23. So you can imagine that as 17, take away 17 first, and then an extra 6. So it's going to be -6. That's the reason why x is equal to 6 after taking away the negative sign from both sides. Yes, that's right, Simon. Okay, so we are done on these questions with 1x only. Next, we are moving on to some questions with more of these x. Okay, so there's going to be, sorry, who's that?
Wait.
You're having a bit of background noise over there. You just try to mute yourself a little bit. Thank you. All right. Okay. So next we are moving on to some questions with more than 1 x terms. So now you can see that in this sub-question 1, wow, there's 1, 2, 3, 3 of these x terms. That's exciting. So how do we solve these kinds of questions? First of all, we need to clarify one thing, that x is an unknown, but it doesn't mean that it can change. So in a single equation, all the x are representing the same number. We just don't know this number yet. And that's the reason why we can operate the x terms themselves. For example, we can just imagine that these unknowns are just like apples. If I have 3 apples and I take away 1 apple, that's going to be 2 apples. So if I have 3x and I'm taking away 1x, that's going to be 2x. All right, so we can operate on the x terms. We can operate on the number terms, but we can't cross-operate the x terms and the number terms. Okay, so for the questions which we have more than 1 x terms, I need to split them up. And by splitting them up, I mean that I want to put all the x terms on one side and all the number terms on the other. Okay. But then the first step is always to operate the terms that you can. So for example, in the first question here, I have 5x take away 9 take away x equals 2x take away 3. But before moving the x terms onto one side and the number terms on the other, first, I need to operate the terms that I can, which means that you can see that on the left-hand side, I have 5x, I have x, which means that I have 2 of these x terms. And if you still remember what I said earlier, the x terms can be operated with each other, which means that if I am taking x away from 5 of these x, what I have left is just going to be 4x. All right, so the 4x comes from 5x take away x. And for the minus 9, I just keep it right there, 4x take away 9. That's what I have left on the left-hand side. And on the right-hand side, there's nothing I can operate because I can't operate x term with a number term. So I just leave it unchanged like that. Okay. So the next step is moving the x terms to one side, number terms to the other. So now we can see that there's a 2x here, there's a 4x here. I want them to be on one side. So probably I can just move them to the left-hand side, let's say. And how do we move them? Actually, it's just by canceling it out on both sides. Okay, so if I just try to cancel 2x out on the right-hand side by taking away 2x, I know that I need to do the same thing on the left-hand side because that's how we can make the equation stay as an equation. So now I have canceled out the 2x on the right-hand side, which means that all the x terms are now on the left-hand side. And I have done the first part of the second step, which is x terms to one side, move all the x terms to one side. Now, what we are left is the second step. We want the number terms on the other side, right? So now on the left-hand side, I still have minus 9, which I don't want because I want it to be on the other side. So what I can do is just to cancel it out by adding 9. So minus 9 and adding 9 makes a 0. But you need to remember adding the 9 on the right-hand side as well. Okay. So do every operation on both sides. That's the key of success algebra. Okay, so now I can cancel out the number term on the left-hand side, and now I have the 9 on the right-hand side. So what I have on the left-hand side, which is left behind, is 4x take away 2x. What I have on the right-hand side is 9 take away 3. So we know 4x take away 2x is just 2x. 9 take away 3 is 6. If 2x is 6, then what is 1x? Oh, Joshua, you can't see anything. That's weird. Yes, that's right, Jarek. Yep, maybe it's an internet issue, Joshua. You can try to re-enter the classroom. That's right, we just need to divide 2 from both sides to get x. So when 2x is 6, if you divide 2 on both sides, 2 divided by 2 is 1. So I have 1x left. 6 divided by 2 is 3. So x is 3. All right, that's how I solve this equation. Good. And then moving on to the second one.
Tiger,
Uh,
this, I just don't really get how you get like 2x equals 6.
oh, 4x take away 2x is 9 take away 3, isn't it? So 4x take away 2x is 2x.
Yeah.
9 take away 3 is 6. So that's how I get 2x is 6. Just by operation, just calculation, okay? All right. So in the second question here, 17x take away 3 is equal to 9x adding 9 adding 5x. So again, we have 3 of these x terms. We have 3 of these x terms. Yeah, that's okay, Yanchen. So after we write it down, we can see that on the right-hand side, this time it has 2 x terms. We know that we can operate the x terms whenever we can. So I can just add the 9x and the 5x together first, which is going to make 14x, because 9 adding 5 is 14. So 9x adding 5x is just 14x. And we keep the adding 9. We keep the adding 9 as it is. All right. And then what's next is just going to be writing down the same thing on the left-hand side. And we're done with this step. Sorry, can you just try to mute yourself, whoever that is? You're making a little bit of sounds there. All right.
There's a lot of people who are unmuted.
And the next step is that I can move x terms to one side, number terms to the other. So I can probably just cancel out the 14x because it's the smaller quantity. So we want to cancel it out, right? And then I don't have any x on the right-hand side. All the x are on the left-hand side, which means that the next step is going to be moving all the number terms to the other side. So I don't want any number terms on the left-hand side now, which means I just cancel out the number term on the left-hand side and do the same thing on the right-hand side, which is adding 3. So now I don't have any number terms on the left-hand side. I don't have any x terms on the right-hand side. So let's copy down what's remaining. 17x, take away 14x is equal to 9 adding 3. So on the left-hand side, we can do the operation. 17 take away 14, that's 3. So it's 3x on the left-hand side. On the right-hand side, 9 adding 3 is 12. So I have 12 on the right-hand side. So if 3x is 12, yeah, that's right. That's right. If 3 times x is 12, we can just divide 12 by 3 to find x, right? Because this is just an unknown. 3x means 3 times of x. So the inverse operation of times, that's going to be division. So we divide every side by 3. And now I get an x on the left-hand side. I get a 4 on the right-hand side. Yep, that's right. That's right. X is equal to 4.
No.
Okay. And just one last question right here, which is very, very, very similar. So if you already understood what I say, you can just try to work it out on your paper, right? You don't even need to bother listening to me for this question because like it's so similar with the previous two. So what I have on the left-hand side is 2 x terms. On the right-hand side, I have 1 x term, which means that I can operate on these 2 x terms together, yeah? So 13x adding 1, take away 4x is 6x adding 10. On the left-hand side, I can just directly do the subtraction between the x terms. So I get 9x adding 1, just keeping the adding 1 unchanged. And on the right-hand side, 6x adding 10. Okay. Yeah, many of you are getting the answer already. That's nice. So then we are moving x on one side and numbers on the other. So we cancel out the smaller quantity we have. So x is on the left-hand side now. And then we cancel out the number term on the left-hand side. So all the number terms go to the right-hand side. Sorry? Is anyone asking any questions? Okay. 3x is what we have left from 9x take away 6x. And on the right-hand side, 10 take away 1, that's going to be a 9. So if 3x is 9, we can just divide 3 on both sides to see that x is going to be 3. So x is 3. Oh, if you get 3x is 11, that might be because you did this step wrong. You need to take away 1 in order to cancel the 1, not adding 1. If you add 1, you can't cancel out the 1, right? You need to take away 1 to cancel out the 1. So that on the other side, I have 10 take away 1 as well, because I need to do the same operation on both sides. So that's how you get a 9 on the other side. Okay? All right. Sorry, who's speaking? Well, if you have any questions, of course, you can ask me about it, but try to be quiet or, maybe mute yourself so that, well, everyone else can hear me talking. Okay, so that's, yes, Yushin, any questions?
It was an accident.
Okay. All right, we are good. So this is going to be the last question of, like the pure algebra. And next, after this one, we're just moving on to some word problems. So this question is involving some multiplication of brackets or whatever. But actually, there's a simpler way to solve these questions. Well, I'll show you both ways, okay? So first of all, the first way of handling these questions is that you can see that I have some brackets in this question. And when I put a number outside the brackets in algebra, it means that 3 is multiplying to whatever is in the brackets, x minus 4. And that's equal to 6. So it means that actually this equation is equal to 3 times x take away 4 is 6. So now I can just try to divide 3 from both sides without operating through the brackets. So what I have left is x take away 4, which is inside the brackets. And on the other side, I have 6 divided by 3, which is 2. So immediately, this becomes pretty simple, isn't it? x take away 4 is 2. So we just need to get rid of the 4 right here. Take away 4, basically. And in order to get rid of it, I just need to add 4 to both sides. And that's how I can find the answer. 2 adding 4 is 6, where the 4 terms are cancelled out on the left-hand side. So for the first one, it's going to be 6. Okay? But sometimes it's not that easy. Sometimes you cannot just divide the number on the outside of the brackets. So I'm just going to teach you another technique, which can definitely solve any algebra involving brackets. All right. So that's going to be a little bit related to the distributive law of multiplication. For example, if I have 3 times 1 adding 2, what is that going to be? We know that by bitmas, we should calculate whatever in the brackets first. So 1 adding 2, that's in the brackets. So it's going to be 3. So the answer should be 3 times 3, which is 9, right? Yeah, that's right. It's 9. And then, according to the distributive law of multiplication, it means that for the 3, multiplying whatever is in the brackets, adding or subtracting each other, I need to multiply the 3 to every term within the brackets. So that's what we call the distributive law, because like I am just like distributing the 3 to all the terms inside the brackets. So I have 3 multiplying 1, adding, so the adding comes from there, 3 multiplying 2, which is also 9. Excuse me. Okay, so that's the basis of distributive law. So after knowing the distributive law, we can definitely apply the distributive law to the equations as well. We can definitely apply it to the equations. So of course, you can just do this question as what we did just now, dividing 2 on both sides. Or the other way is that you can just try to multiply the 2 to each term within the brackets, or distribute the 2 into the bracket to everyone in the bracket, okay? So what I can write from this equation is 2 multiplying 3x, adding 2 multiplying 2. So the first 2's, they come from this 2, and 3x and 2 are the terms in the brackets, and that's 28. So now after some calculation, 2 times 3x, that's going to be 6x. 2 times 2, that's going to be 4. And 28 is just 28. So now I can take away the numbers because I don't want the numbers together with the x. They are not friends. They are just not like each other. So they won't be staying together. And I need to do the same thing on the right-hand side as well. Take away the 4. So now I cancel out the number terms on the left-hand side. What I have left is 6x on the left-hand side and 28 take away 4, which is 24 on the right-hand side. And then I just divide 6 from both sides to get rid of the extra number. So what I have is x on the left-hand side and 24 divided by x, which is 4 on the right-hand side. Okay, so that's how I get 4 as the answer, 4 as the answer. So for the last one, of course, whichever way you prefer, but for this question, definitely what's easier is just to divide 7 from both sides, because we can see that 21 is a multiple of 7. So why don't we just divide 7 on both sides to get rid of the brackets? So I have 7 times 2x take away 9 equals 21. So by dividing 7 on both sides, what I get is 2x take away 9 equals 3. And then the next step is, of course, getting rid of the number on the left-hand side because it's got an x term there. So I add 9 to both sides just to cancel out the minus 9 on the left-hand side. And the next step is going to be 2x equals 12. And finally, divide 2 from both sides. So what I get is, well, let me just write another line. Divide 2 from both sides to get the answer, because I don't want the extra 2 here. I don't want 2x, I just want x. And I know x is half of 2x, so I just half both sides to make the equation stand. So x is therefore equal to 6. Okay. Are we all good so far? Are we all good so far? Yes, Simon.
I actually have a little way. So first of all, so for example, the first one. So what I did was, 3 times 2 is 6. So I mean,
sorry, I have to stop you there, Simon. I mean, that's a great method. That's definitely a great method, and it works for these kinds of questions. It's just that, well, you know, like you have to adapt to the algebra kind of thinking, you know. So like, I definitely think that's all right, because it helps you solve this question properly. So you know that 3 times 2 is 6, so 2 is x minus 4. That's definitely okay, but like just try to adapt to the equation thinking, which is like making the same operation on both sides. Because like later on, if you have some more complicated algebra, you might find it really struggling. Like you might find yourself really struggling when you're getting through these questions. Okay, so my suggestion would be just try to do the same thing on both sides for any algebra question, even though it might be taking a little bit more time than your own way, because like that is what I call a good habit. It's only when we establish the correct habits, the good habits, and we will be able to learn about more complicated algebra. Okay, so these questions are easy, I know. Yeah, definitely they are. And I appreciate that you all understand it. But remember our goal today. Our goal is to consolidate everything we know about algebra. And the reason why we consolidate it is to move on to some more complicated questions, some more interesting questions later. Okay, so I hope you all understand. Yes, of course. Yes, of course. Go ahead. All right, thank you, Simon. So next, we're not just gonna do anything such boring, you know, like solving plain algebra. You might wonder why you solve it. Where does this come from? So the reason why we learn algebra at all is because like algebra is just kind of a tool to help us solve some complicated questions or less complicated questions, whatever. But it's just a tool. It's just like any other operations. It's helping us to solve problems. And here, what I'm trying to do is I'm trying to tell you how we can convert what problems we see into algebra calculation to find the answers. Okay? So let's read the question together first. Bud is ordering some snacks for a party. She orders 2 pizzas and 5 sets of hot wings. Nice. And it's charged a total of £23, 10 pence. So how much is a pizza if each pizza costs 3 times as much as a set of hot wings? All right. So in order to set an equation, we need something which is the unknown. Remember, in all the equations we have previously, we have one thing called the unknown, or what we mark as x. But that's pretty intuitive because we know that in any questions, there's got to be something that we don't know, right? So whatever we don't know, we just set it as the unknown. But in this question, we can see that there's the price of pizzas, there's the price of hot wings. So there's actually two unknowns. Do I need two unknowns actually? Not necessarily, because we can see that the question already gives us the relationship between the two unknowns. That is, each pizza costs 3 times as much as a set of hot wings. So we know that, well, we can write pizza, pizza equals 3 times wings. Yeah. So now I just need to set one of them as the unknown, and I will be able to express the price of the other in terms of the same unknown. And how do we choose? How do we choose which one I should set as the unknown? There is a pretty simple principle. All right, I'm just going to repeat it again and again and again until all of you remembers this. The principle is choose the smaller one as the unknown. Choose the smaller one as the unknown. Choose the smaller one as the unknown. Okay, are you all remembering this? Choose the smaller one as the unknown. So if the pizza costs 3 times as much as the wings, which one is smaller? Which one costs less?
Pizza.
The wing.
Pizza? Who said pizza?
Wings.
Yeah, wings.
Wings,
Definitely. Wings, definitely.
Wings,
yeah, that's right.
Pizza's just 3 times as
Wings.
Yep. So
That
wings.
means pizza would be 3.
Yeah, that's right. Wings is the smaller quantity.
Pineapple.
Come on. All right. So we just need to let X pounds be the price of a hot wing. And we know that pizza costs 3 times as much as that. So it's going to be 3x pounds be the price of a pizza. Okay. And now I am able to write an equation. We know that Bud orders 2 pizzas and 5 sets of hot wings. So 2 pizzas is going to cost 2 multiplying 3x pounds, because each pizza is 3x. So 2 pizzas is going to be 2 multiplying 3x. As for the chicken wings, the hot wings, 5 sets of them. So each set is going to be x pounds. So 5 multiplying x is the price of hot wings. And that's a total of £23, 10 pence, which as a number, we just write 23.1. So now on the left-hand side, I can see many numbers that I can operate. 2 times 3x, which means 2 times 3 times x, that's going to be 6x. 5 times x is just 5x. Yes, Yashi? Any questions?
How did you get 2 times 3x add 5 times x equals 23?
That's 2 pizzas.
Yeah.
Each pizza is 3x pounds. I write it there. So 2 pizzas is 2 times of 3x pounds, right?
Yeah.
So that's the price of pizzas. And for the hot wings, each hot wing is X pounds. 5 of them will just be 5 times of X pounds, right?
Okay, thank you.
Okay, so that's how I write this equation. All right, so now on the left-hand side, I have 6x adding 5x. And I know that I can operate it. It's just going to be 11 of them altogether. And on the right-hand side, it's still 23.1. So we're just going to do a little bit of division. That's just x. Yes. Yeah, and that's just a little bit of division. Decimal division, another thing that we're going to talk about in the last revision class. So for now, let's just accept the fact that 23.1 divided by 11, because we need to divide 11 on both sides to cancel this 11. It's going to be 2.1. All right. So we know that x is 2.1. So how much is a pizza? A pizza is just going to be 3x, right? So 3x is equal to 3 times x, which is 3 times 2.1. As I know, x is 2.1. So it's 6.3. And that's the price of a pizza, £6.30. Okay. Yes, that's right, Kiki. That's right. All right. So basically, all you need to remember here is whenever you see a word problem and you have decided to solve it with algebra, the first thing you need is to find the unknown or the unknowns in the question. And after you find the unknowns, set the smaller one as the unknown and express the other one in terms of the smaller one. Okay. And then the next step is to write the equation according to the description of the question, which might actually be the hardest step, but you all know English, right? You all know English. So whatever it says, just do whatever the question says. Write it down, and that's it. Okay. Yeah, pretty much it. That's just how we solve word problems with algebra. All right, so next. This is getting an upgrade here. All right, any questions? Anyone who's raising their hand? Any questions? Nope. Okay. So Charlie, you do. What's your question?
Do we have homework after this?
Nope.
Okay.
Yeah, congratulations. You've got no homework after this.
I just had a class yesterday. Tiger, are you going to send us all the recording?
Yes, I will, definitely.
Okay, thank you.
Okay. Who else? Any other questions? No? All right, let's move on. So Charlie, yes, Yashi, any questions?
No, sorry, I forgot to put my hand down.
Oh, that's fine. All right. So this Charlie guy, it's the third time I'm talking about him. This Charlie guy is solving some puzzles. It takes him 10 minutes to solve 3 puzzles. The second puzzle takes him 1 more minute than the first one, while the third puzzle takes him twice as long as the second one. Fair enough, that's interesting. How long does it take Charlie to solve the first puzzle in minutes and seconds? So basically, let's just try to determine which one is the smallest quantity among the 3 puzzles. Which one takes the shortest? Probably we can just compare the second one to the first one.
Puzzle 1.
Sorry, what do you say?
I think it's puzzle 1.
Puzzle one. So it says that the second puzzle takes him 1 more minute than the first one, which means that, well, the first one is smaller than the second one, while the third puzzle takes him twice as long as the second one, which means the second one is smaller than the third one, which means the third one is larger than the smaller one is larger than the first one. So the first one is the smallest. Is that making sense for everyone? The first one is the smallest. Yep. Okay. So if the first one is the smallest, of course, we know what we need to do is to set the first one as the unknown. So we can say let x minutes, or because the question says minutes and seconds. So probably, I think the safer way is to let it be some seconds, unless you want some decimals coming up, which of course we don't want. So let's convert everything into seconds. All right, so let x seconds be the time we need for the first puzzle. And it is strongly recommended that you write these kinds of sentences down, because otherwise, while you are calculating it, you might forget about what you set as x originally. Okay? That actually happens. Believe me. You might forget about what you set as x originally. So in order to prevent that from happening, I strongly recommend all of you to put a sentence down, reminding yourself what is x in the very beginning when you're solving problems with algebra. Okay. Yep. So if the first one is taking x seconds, so seconds, okay? The unit is seconds here. So the second one is taking him 1 more minute, which means 60 more seconds, right? So 60 more seconds, x plus 60. And that's the time needed for the second puzzle. And the third puzzle takes him twice as long, which means that we are multiplying x adding 60 by 2, which means that that's going to be 2x adding 120 for the third one. Altogether, these 3 puzzles altogether takes him 10 minutes. So the first puzzle, x seconds. The second puzzle, x adding 60 seconds. The third puzzle, 2x adding 120 seconds. So I'm adding all of them together. I'm adding all of them together. And that's a total of 10 minutes. So throughout the whole equation, we need to make sure that all the units are aligning to each other. So we don't write a 10 on the right-hand side. That's going to be in 10 minutes. No, we want everything to be in seconds, remember? We want everything to be in seconds. That's why we can just operate seconds with seconds, not seconds with minutes. So I need to convert 10 minutes into seconds, and that's going to be 10 multiplying 60, which is 600 seconds. So on the right-hand side over here, I have 600. Now, I just solve this equation, and that's going to give me everything, which means I can operate the numbers 60 and 120, adding up to 180. I can add up all the x, 1x, 2x, 4x. So x, 2x, altogether, that's going to be 4x. And that's 600. I just leave the right-hand side as it is. So now I remove the number from the left-hand side. Hope you still remember that technique. I just do the same operation on both sides and cancel out what we have on the left-hand side. So now I have 4x equals 600, take away 180. That's going to be 420. Then I divide 4 from both sides. So I have x on the left-hand side. I have 105 on the right-hand side. That's coming from 420 divided by 4, 105. So lastly, we still need to answer the question. So we don't write 105. That's not the final answer. The question is asking us, how long does it take in minutes and seconds, right? In minutes and seconds. So it's going to be 105 converting into minutes and seconds. So it's 1 minute, 45 seconds. And that's 105 seconds. Yep, that's right. That's right. So the answer is 1 minute and 45 seconds. Okay. All right, so this is how it works. And now let's just try to look at one last question, shall we? One last question. 10 seconds away from the answer. Wow, that's not bad. That's not bad. Pretty impressive. So let's take a look at the last question we have. So there's some motorcycles, SUVs, and sedans in a parking lot. There are twice as many motorcycles as SUVs and the same number of SUVs as sedans. If all the vehicles have 84 wheels altogether, how many sedans are there? So it says that motorcycles have 2 wheels, while SUVs and sedans, they have 4 wheels. So now, again, we are having 3 unknowns in the same question, right? Motorcycles, SUVs, and sedans. Which of them is the smallest unknown? Is it going to be motorcycles, SUVs,
Motorcycle.
or sedans? Motorcycles? Read the question carefully. Twice as many motorcycles as SUVs. Do you think that's going to be less motorcycles than SUVs? Come on. You need a proper
Either
five.
SUVs or sedans.
Yeah, that's right.
Either.
Either.
Because if you have if each motorcycle has 2 wheels, but then there is double the amount of that, and each SUV and sedan is 4 wheels. So if you double it, then all 3 will be the same amount.
Okay.
Really?
Yeah, but then we're just looking at the numbers. We're just looking at the numbers of each type of these vehicles. So obviously, according to the question, twice as many motorcycles as SUVs, which means that there's going to be more motorcycles than SUVs, right? So SUV will be the lesser quantity, and it's the same as sedans, which means that sedans are also the lesser quantity. So we can say that we can just let X be the number of SUVs, which means that the number of sedans is also X, where the number of motorcycle, that's twice as many, which means 2 times of X, and that's 2X. Motorcycles cycles. All right. 21, really? Really? Come on. It's talking about wheels. It's not talking about total number of vehicles. Remember, in every question, a sedan is just, you know, like the random kind of vehicles you're going to see on the street.
It's like it's
And
like
what's an SUV?
SUV is like a bigger type of those common cars that you're going to see on the streets.
Multiply the amount of motorcycles by the amount of wheels they have.
SUVs are like
wheels
lorries.
All right. That's not important. That's not the focus of this question. We're just getting to solve this algebra. All right.
Multiply the amount of motorcycles they
talking
have
about
by
the
amount
wheels.
of-
It's talking about the wheels. So if every motorcycle have 2 wheels, then 2x motorcycle is going to have 2 times 2x that many wheels, right? And then for each of the SUVs, it has 4 wheels. So we are adding that. So 4 times the number of SUVs, which is x. Each SUV has 4 wheels. So altogether, SUVs have 4 times x wheels. And that goes the same for sedans. Each sedan has 4 wheels, and there are x of them. So 4 times x. Altogether, that's 84 wheels. So that's pretty simple now. 2 times 2x, that's 4x. 4 times x, that's 4x. 4 times x, that's 4x. So 3 of these 4x adding together, that's 84. And 3 of these 4x makes 12x altogether. And that's 84. So now x, if I divide 12
7.
from
X
both
equals to
sides.
7.
Yes, very good, very good. That's right. If I divide 12 from both sides, I can cancel out the 12 on the left-hand side. So x is what we're remaining. And on the right-hand side, we know 84 divided by 12, that's 7. So the answer is a 7? Well, let's see. Every time we get the x, that's when you are easily making a mistake. Because you should remember what the question is asking you about. So the question is asking you about how many sedans are there. So let's go back to what we have written down at the very beginning. What is x? So x is the number of SUVs. X is also the number of sedans, which means that there are, well, actually, yes, that's right, 7 sedans. So in this question, we're just looking for x. But that's not always the case. For example, what if this question is asking for the number of motorcycles? Then it's going to be 2 times x, which is 14, right? So if you just write down the value of x, then you might get it wrong. So make sure you double check the question after you're done with the algebra, and you double check these, whatever you have written down at the very beginning, to make sure that what you're looking for is actually what the question is asking. All right. So these are everything I can tell you about simple linear algebra and how to do problem solving, like of word problems or word problem solving. So basically, this is everything. Does anyone have any questions for me?
Yes. Is there going to be lots of revision lessons after this?
Sorry, what revision lesson do you say?
Like today's, like will there be any more?
Oh, yes, there will be 2 more of these revision lessons. The next one is going to be next Monday, and that's going to be on the simultaneous equations. All right, so how to solve simultaneous equations.
Have homework.
No. So good for
Yeah.
you. We
Yeah.
don't have homework for this revision class. But if you
But
want any
because-
homework, feel free to ask Mr. Tiger about it. I'll be happy to give you some homework.
Oh, I don't
No,
want
don't give us
homework.
homework.
First,
No,
I
no
don't want
homework.
homework. Second,
Okay.
my tummy's hungry. Third, I'm hungry.
Okay. Yeah, go ahead to
Tiger.
eat some food, Jerry.
Okay,
And the
bye.
food is done. And the food is done. Do you like cats, Tiger?
Yes, I do. I do.
Should look at this. A cat eating noodles.
Okay, thank you. That makes my day. Yes, Joshua, do you have any questions for me?
Who's Joshua?
Do you still have a dog called Walnut?
Yes, I do. I do.
You do?
Yeah, I do have a dog
Tiger?
called Walnut.
There's some
Do you like pandas?
Pandas? Who's talking
Sounds
about
like
pandas?
Bye.
All right.
Do you like
Bye.
pandas?
Bye.
Okay, that's going to be everything of this lesson today. Thanks all of you for coming.
Bye.
Bye.
Do you like tiger?
All right.
Do-
Bye-bye. Oh, and
Bye.